doing last time here. So what we want to do with this kind of thing, now when we get into next week's test, usually I have you fill out a table of values and then do a graph. You have a graphing calculator. How can you miss your graph? You know what I mean? Okay, because if you know how to use your graphing calculator good, which I want you to know, then you can tell you're doing the graphing right. You really can. Okay? All right. So first of all on this one, this has got a second power. So the elementary function that we're going to graph first of all is y equals x squared. Now we're just going to graph that to begin with. And this is generally what I have you do on an exam, is I just say, okay, graph the elementary function. So we're going to make a table of values down here, and we're going to use these values. Okay, those are generally really good values to use when you're making your table of values, unless it's a square root or something. Okay, you can do all this in your head. So if you do negative 2 squared, that's 4. If you do negative 1 squared, that's 1, and so forth. 0 squared is 0. 1 to the second's 1. 2 to the second's 4. All that stuff there can be just processed in your head. Now what you want to do next is you want to go ahead and plot those 5 points on the graph that I gave you. And then I'll have you kind of use like a dashed curve on that. So we're going to go left 2, up 4, left 1, up 1, 0, 0, 1, 1, and then over 2, 4 like that. So that's the elementary function, and we're going to kind of move it around with what we call transformations. So that's what we were working on last time. Okay, so that's y equals x squared. Anybody have a question about what I did there? Okay, let me see if we remember what we were talking about last time. Okay, so first of all, we want to look at this. Do you know what the x plus 2 does? That 2 is inside the function, so what did we say last time? That's left 2. So you got to know these transformations and study those. So the first thing you're going to do is you're going to move every point to the left 2. Okay? All right. Now the next thing is this thing, and you have to do these in an order. Now what that does, the negative causes it to reflect. The 1/2 flattens it out. Okay? But what you probably want to write on your paper, it's just as well to write it this way. Just write multiply y values by negative 1/2, because you'll understand it better that way. Okay, because you want to know how things get stretched and shrunk. Okay, and that's what we're going to kind of look at on that. Okay, last thing is the -1. That's outside. What does that do? That's down 1. Okay, one of the things that you want to get in your mind on these things is you're following the order of operations. So what I'm talking about by that is this. If you plugged in a value for x, what you would do is you would do what's in the parentheses first. That's what order of operations says. So that means the first thing we're going to do is move all those points to the left 2. The second thing you do is multiply, then you would add or subtract. Right? That's order of operations. Exponent, then multiply, then add or subtract. That's why we do it in the order we do. Okay? Now, what I'd like to show students is this, and on the test, I have you fill out this table, because I think it'll help you keep track of everything. So the first thing we're going to do, these are the points you just plotted. So let's write down left 2, and then we're going to just focus on that right there. If you do it this way, it's very methodical, and as long as you know the order and what the transformations are, then it's pretty easy. All right, so if you're going to make all the points go to the left 2, what do? Do you change x or change y? Change x, right? X is a measurement of left and right. So what we're going to do, and you're going to do this in your head, is you just make all of these x values that I just highlighted, make them go to the left 2. You don't have to even write anything down. You do it in your head. Negative 2 to the left 2 is -4. Negative 1 to the left 2 is negative 3. 0 to the left 2 is negative 2, and you'll start seeing a pattern here. 1 left 2 is negative 1, and then 2 left 1 is 0. Okay, so I'm taking all those x values and making it smaller, but I'm not going to change the y values. I'm not ready to do that yet. So I just write those things down there. Okay, so step 1 is all those points get moved to the left 2. Everybody understand what I did there? Okay. Step 2 is going to be multiply. This will do the stretch, shrink stuff and the reflect. We multiply y by negative 1/2. Okay. So that means in this step, you're not going to do anything to the x values. So I would just bring down the x values and leave them alone. And then we'll start adjusting the y values like that. Okay, we got the x's where they need to be. Now what you want to do is, in your head, just multiply all those things by -1/2. Okay, you're just cutting it in half and changing the sign. Okay, I'll write a few of these down at the side. You can write down if you need to. But if you do -1/2 times 4, that's -4/2, so that's -2. Okay, generally it's pretty easy to cut a number in half like that. Okay, and then the next one, you have a y value of 1, so you do -1/2 times 1, which is -1/2. Okay, so I'm just multiplying each of those y values by -1/2. Okay, and then the rest of this, just do it in your head. What's half of 0? Still 0. What's half of 1? A half, and it would go back to -1/2. And what's half of 4? 2, right? Okay, -2. I'm multiplying all those by a -1/2 to get those values in. Okay, and if you do it in your head, just do it in your head. Okay, and then this one would go back to -1/2, and then this one would go to -2 like that. Okay, that's step 2 is that part. What's the third step? What did we say? Down 1. So if I want to make the graph go down 1, do I change x or change y? All the y's get smaller, okay? So that means when you go to step 3, you don't affect the x's. You just keep bringing those x's down. We took care of that in step 1, so we have that. Okay, now just look at all these y's. You can do this in your head. Make them all go down 1. Use your calculator if you have to. So -2 minus 1 is going to be -3. -1/2 minus 1, you can use a decimal if you want to. That's -1.5. 0 minus 1 is -1, and so forth. Then they just go back to repeating themselves. So that one's -1.5, and then that's -3 like that. So I did 3 steps. Now what you need to do is that last row, you need to plot those points, and then that will tell you where this graph ends up then. So what you want to do next is go up to the graph and then just plot those points, and then we'll have it done. Okay, and that's a good way to kind of keep track of these more complex problems where you have transformations. Okay, all right, so let's go ahead and plot these then. So we have -4, -3 would be the first point. We have -3, -1.5, you just kind of estimate. Then we have -2, -1, and then we have -1, 1.5. Then we have 0, -3. Okay, so if you get those points plotted correctly, that's where your final product went. Okay, so here's what you do now. All right, first of all, did it reflect? Absolutely, that's pretty obvious, okay? Did this point move to the left 2 and down 1? Yeah, every point really did. Does it look like it's a little bit wider? Right, that 1/2 made it kind of shrink this way, kind of stretched out that way. So that will have all the transformations we have. Okay? Does that make sense what I did? Okay, now you got to follow this order. You got to do that first, then that, then that. Okay, and if you do a table, that's a real good way to process and keep track of it all. That's the idea. That's why I try to teach it that way, because sometimes students have a hard time processing that. Now you can put that in a graphing calculator if you're doing a test. I mean, you can put it in a graphing calculator and make sure it's right. So I'm not against that. Okay, so think about that. Make sure you know how to use your calculator. Okay, any questions about what I did? Yeah.
Is that like a vertical stretch or shrink? Or
vertical shrink is what it is. And it's always opposite. So if the opposite of vertical shrink is horizontal stretch. On this problem, it's probably easier to see that you're stretching horizontally. So this thing, if you stretch that out, you kind of get what you got there then. Okay? But I prefer you just write that like multiply y by -1/2 so you understand what to do. Okay? All right, let's go to piecewise functions. Okay, so piecewise functions, we're going to work a little bit on that today. All that means is you have 2 or more functions defined on intervals. Not going to do anything down here on this page. This is just a couple of examples of what they look like. So this one has 2 functions, that one has 3 functions. And when you graph these, you just have to do separate graphs. Okay, so we're going to go to the next page. I'm going to do 2 examples, and I'll let you try to maybe do one of these in class here. All right, now here's what I recommend. And when you do this on next week's test, this is how I lead you through it. I have you make tables of values, then I have you go through and put and then do the graph. Okay, so let me talk about how you do the table of values. Okay, the first thing is we're going to graph y equals 2 minus 2x. Now here's what you have to pay attention to. This part right here tells you what you can use for x. So what you have to do is you have to use numbers smaller than 2. That says x less than 2, so that's what you have to do. So what you want to put here is you start with a 2, even though it says smaller than 2, you got to know where that graph comes to an end. And then, since it's less than, there's not an equal there, your graph is going to have an open bubble at the end, so I would recommend you put an open bubble to remind yourself of that. Okay, now just start picking numbers smaller than 2. 1, 0, that's good enough. All we need is 3 because that's a line anyway, and it only takes 2 points to make a line anyway. Right? Now we work it out. So we're going to do 2 minus 2 times what x is. We'll just calculate 3 points out. That's good enough. You can do more if you want to, but I think that's sufficient if you just get those points like that. Okay? All right? And you can use your calculator, of course, on your arithmetic or do it in your head. This would be 2 minus 4, so that would be negative 2. The next one would be 2 minus 2, so that's 0. And then the next one would be 2 minus 0, so that would be 2 like that. Okay? Does it make sense why I'm choosing the numbers I did? That's usually the question students have. Okay? That's because of this statement. You got to pay attention to it. You start with 2 and then go below 2. Okay? That's it. Okay? That will tell you what range of numbers you do. Okay, now what we're going to do is go ahead and plot these 3 points. Go ahead and just graph the 3 points. So the first one is 2, negative 2, and you put an open bubble there. And the reason we did that is because that 2 did not have an equal to bar on it. If it did have an equal to bar, it'd be solid. Then graph 1, 0. Then graph 0, 2. And then you're going to go to the left of that. Okay? Now this is what students do all the time, is they want to just draw the line this way. Why does the line not go this way? Because of that. That says this graph is for x's smaller than 2. Okay, so don't go further. Don't go any further. That's piece 1. That's why we call this a piecewise function. Does that make sense to you? Okay, 2 and less than. Okay, don't go any further. All right, now the next thing we do is we do the second piece. So now we're doing x minus 2. What kind of numbers do I need to use on this piece? 2 or bigger, right? Okay, so start with 2. Since there's an equal to bar, put a solid dot, and then just pick some numbers bigger. 2 or 3 is good enough on a line. All you need is 2 good points for a line anyway, okay? Then start crunching. Plug into your function, so we'd have 2 minus 2 is 0, 3 minus 2 is 1, 4 minus 2 is 2, and then you got enough points to plot, okay? All right, and let's see, I'll do this in a different color. So we got 2, 0, that is solid. Then we have 3, 1. Then we have 4, 2. And which way is that graph going to go? It's going to go to the right. Okay, it's going to the right of 2, so it goes like this. All right? Whoops, what in the world did I do? Okay, so that's what your graph looks like. That's it. Now what I did is I did 2 graphs, but the first one was less than 2, that's what it said. The reason the bubble's there is because that's less than. And then this one is to the right of 2. The reason it's solid is because of the equal to. Does that make sense, students? Okay? So but to me, the best way to learn how to do this is just do 2 tables of values and plot points. Okay? As long as you can do your arithmetic and plot points, you should be okay. There's other ways to show students. This is probably the simplest. Now, I'm not going to do anything with the calculator on these. If you're interested in learning how to do it on the calculator, you can come by and see me, but I'm not going to do that in class, okay? And you can also go YouTube. You could go how to graph a piecewise function on a TI, and you will find it, okay? So if you're interested, you can see me or look it up, okay? That would be handy for next week's test, of course. Okay, so let me do one more. And then I'll let you try to do one in class to see if we can kind of absorb this okay. So the first thing we're going to do is x squared minus 3. What kind of numbers do I need in my table? 3 and smaller, okay? You start with 3. Is that 3 solid or open? Solid because equal to, okay? So you got to pay attention to that. Okay, now let's just pick some numbers smaller than 3, like 2, 1, 0, negative 1. This is a parabola. It's going to be a curve, so it's a good idea to choose several points on that. Okay, now what you want to do is, again, you just plug in. You're doing something squared minus 3. And if you're confident doing all this in your head, then you can go for it. Okay, I'm just going to kind of write down on each one of these what I'm doing. Okay, so the first one I'm doing 3 squared minus 3. When I plug in the 3, that would be 9 minus 3, so that's going to be 6. The next one you plug in 2. 2 squared minus 3 is 4 minus 3, so that's 1. And then you go to 1. That would be 1 minus 3, so that's negative 2. Plug in 0. That gives you negative 3. Plug in negative 1. Now the negative 1 squared becomes 1, and 1 minus 3 becomes negative 2. Okay? And don't mess up on your arithmetic. You've got a calculator to use, so if you have to do that, do it, okay? All right, so what we're going to do is plot these points. And let's see, on this one we'll have 3, 6, and then that will be a solid dot. That's important to have a solid dot there. Then we have 2, 1. Then we have 1, negative 2. 0, negative 3. And then negative 1, negative 2. Okay, and that's good enough. What you do on this is you just kind of connect it. Then you go on forever that way. Okay, and again, the thing is, this is what I see students do all the time. Why does this graph not continue this way? Because that's what it says. Okay, yeah, that's what you have to pay attention to. Okay, so you're always going to have 2 parts of the graph. They don't go on forever. Okay, that's just they have pieces of it. Okay, the next one is y equals 6. Okay, what does the graph of y equals 6 look like? I hope you just know that. That way, right? It goes through y equals 6. Okay, if you don't know it, well, then you could do this. You could pick numbers bigger than 3. You would start with 3, but it would be open. That's open right there because there's not a bar there. And then you could pick whatever you wanted to, bigger than 3. Well, the thing on this is it's just always 6. There's nothing to plug in for. It just means if y is equal to 6, it means y is always 6. So if you forget that, then you can use a table to figure that out then. Okay, so what happens is we're going to plot these points. So 3, 6, see how that connects? We already had 3, 6, so it connects. So there's no longer an open bubble. It just means we connected there. Then if you do 4, 6, you have this, 5, 6. So this graph will go like that, right? So what you end up having is you have the parabola for everything to the left of 3. Then you got that line, horizontal line to the right of 6. Does that make sense? A lot of students really struggle with piecewise functions, but if you methodically do your tables of values, then you can be okay. Any questions? Okay. All right, so let's see. So the pieces, I'm asking on this is kind of what I was saying. How do you know the pieces join? Is because you get the same number, right? 3, 6, 3, 6, that means they connected. The first example I did, they didn't connect, but they did on this one. Okay? All right. I'll let you go ahead and go to the next page, and I'll give you a little time just to do one problem, just one problem in class. You can help each other if you want, and I'll walk around and give a little help if you don't know what's going on here. But get your table. Okay, so main thing I was looking for, I was just mainly looking to see if I could tell that you knew what numbers to use for x. So this first one, you use 0. The 0 is solid, and then you use some negative numbers. Okay, like that. So that's what you want to do, all right? Then you just do each one of these separate. So 0 plus 2 is 2. Absolute value of negative 1 is 1. 1 plus 2 is 3. You want to make sure you know how to do absolute value. Then negative 2 plus 2, that would be 2 plus 2, so that would be 4. And a lot of times these things have patterns to it, so then if you work out the rest, you would just have 5, and then you'd have 6 like that. All right, so that's what you'd have on your arithmetic. And then when you plot this, you'd have 0, 2 with a solid dot, and then just plot the rest of the points. So if you did the first piece right, that's what you would have on your paper. Okay, and you wouldn't go beyond that to the right, you would stop. That's it. Does that make sense to everybody? Okay. All right, now on the next one, what we do is, again, we're going x greater than 0. You still start at 0, but you have an open circle because that's where it comes to an end. And then you choose numbers that are bigger than 0, just probably some positive numbers like that. Keep it simple, okay? Now what you do is you do the number squared minus 1. Okay, so the first one, 0 squared minus 1 is -1. 1 squared minus 1 is 0. 2 squared minus 1 is 3. 3 squared minus 1 is 8. And then 4 squared minus 1 is 15. 16 minus 1. That's out of range, but that's fine. Okay? So that's the arithmetic you should get. And now when you plot these points, you would have 0, -1. You need to make sure you had an open circle there. And then the rest of the points, if you plot, you have 1, 0, 2, 3, and then we had like 3, 8. So that's what your graph should look like, is exactly like that. Okay, there's the absolute value, and then there's the quadratic, the parabola like that. Okay, most of what I did was arithmetic, right? That's what graphing is, what I've been saying. It's arithmetic and then plotting your points. Okay, you guys, does everybody understand why I chose the numbers I did? That's the key thing. Okay, that's what you have to understand, and then once you get that, do the arithmetic. Okay, should be fine. Okay, any questions? Okay. Okay, so that's a piecewise function. Now we're going to do, to finish this section up, we're going to do actually one application of a piecewise function because it's good for business students to see this because piecewise functions are very common. So I'm going to do just some kind of general graphs next here. This is a general graph that I've already given you on this example below here. And first of all, what you have on this one is, I don't give you the function, I just give you the notation. So there's two transformations going on here. First thing you're going to know is be able to spot them. That x minus 1 is inside the function, so what does that do? Inside the function, how does that move this? It goes to the right one, okay? So you got to know that. You got to study the transformations. So you're going to do, the first thing you're going to do is move all of these points to the right one, okay? All right, what does the plus 1 do? That's outside the function. Adding, what does that do? Everything goes up. Okay, good. So the second thing you're going to do is you're going to go up 1 like that. Okay, now see, I've just gave you a graph on this. So I've given you the points. So we're going to make a table and just kind of crunch it out like this. This one's easy enough to do without a table. If you take all those points and move them right 1, up 1, you got your new graph. Okay, so what I'm going to do, the first thing I'm going to do in this table is move everything to the right one. That's what that x minus 1 says. So that means you're going to change all of these x values in these 4 points. You're just going to make all of the x values get bigger by 1. And you can easily do that in your head. So -3 plus 1 is -2. -1 plus 1 is 0. 2 plus 1 is 3. 3 plus 1 is 4. Everything gets moved to the right one. That's how you do that. The y values stay the same. Okay, so that takes care of that. And then the last thing we're going to do is we're going to move everything up 1. So what moves, if you move up 1, what changes, x or y? Y, okay? All of those numbers and the y values, just add 1 to them. The x's are set. So I'm just going to bring those down, okay? And then I do 1 plus 1 is 2. -3 plus 1 is -2. -3 plus 1 is -2 again. And then 4 plus 1 is 5. If you plot those points, then you got it, okay? So this one right here, if you go ahead and plot your points, you have -2, 1 was a point. No, -2, 2. Sorry, I put the wrong thing on there. So you just plot -2, 2. Okay, then you would have 0, -2, and then 3, -2, and then 4, 5. Okay, and then just connect it into the same shape. That's what you did. Now see that one right there, you don't need to do the table. You just take all those dots and move them right one up one, and you got it like fast. Okay, that's what you need to understand on that. Does everybody understand why it's right one up one? Okay, all right. Okay, inside is x minus 1 is the right one, and then the outside is the up one like that. Okay. Okay, so I think I'm going to do one other one here. Just kind of give you the idea. I'll just let you maybe try to do one, and then we'll finish the section up with an application here. Okay. Okay, so this one, let's look at what these numbers do. That's part of what we're learning in this section. What does that negative 1/2 do? Okay, it does flip it. What else? Kind of, it's the stretch shrink thing, right? But really it does what to the y value? That's what I want you to know. It multiplies y by negative 1/2. Okay, so the first thing we're going to do is you just write down multiply y by negative 1/2. That's better to learn it that way, because then you'll do the crunching right. Okay, what does the plus 2 do in this problem? Yeah. Which way? What is plus? There you go. Up 2. Thank you. Okay, good. Okay, so we do that. All right. So again, you're going to do all of this in your head. So the first step, you don't change the x's on this problem at all. You just multiply all those y values by negative 1/2, and you can do that in your head, or if you need to write it down, write it down. So the first one you would do negative 1/2 times 1. So that would be negative 1/2. Then the second one, you do negative 1/2 times negative 3. So that would be positive 3 over 2. You can use a decimal, that's 1.5. Then the next one is the same thing, it's 3 over 2. So 3 over 2, if you want to use 1.5, you can. And then the next one, you're doing negative 1/2 times 4. So that's negative 4 over 2. So that's negative 2. Okay? So all I'm doing is just cutting all those numbers in half, okay, and then changing that sign. All right, so that's stage 1. Okay, stage 2 is move all of those y values up to, then you'll have where everything goes, and then you'll be able to plot those final points, and then you'll have what that graph looks like, okay? So now what I'm doing is I'm just looking at the y values from the last step and making them all go up 2. So if you did negative 1/2 plus 2, that's 1.5. Use your calculator if you have to. The next one is 1.5 plus 2. So that's 3.5. Same thing here, 3.5 again. And then the last one, you're doing negative 2 plus 2. So that's 0. So all those values I highlighted in yellow, I'm adding 2 to them to make them go up. Does that make sense what I'm doing? Okay, I see there's a lot of arithmetic issues that I see with students sometimes on these with fractions. Use your calculator. Okay, now go ahead.
Why does the x value change?
It never does in this problem.
Or like on, for example, on the bottom it goes from 3 to 4.
Now these are the original points here. So what I did is I just took these 4 points that are on the graph.
That's a 3.
Yeah.
So
I've got negative 3, 1. They all look good to me.
The last
Very last one. Go 4 instead of 3.
Oh, you're saying my last point's wrong.
Yeah, it should be 3 negative 3.
All of your last points are wrong.
Got you. Okay, I always do some little thing like that every time. Okay, thank you so much. Okay. Is that better?
Yep.
Okay, all right. So last point's 3, 0. Okay, now go ahead and plot these. So you would have negative 3, 1.5, so that's kind of up there. Right, then we'd have negative 1, 3.5, so that would be kind of up there. And then 2, 3.5, and then 3, 0. Okay, connect the dots, and there you have it. Okay, everything got flipped upside down. It also kind of got stretched and shrunk a little bit, if you look at it. And then everything got moved up too. Okay, so that's what happened on that problem. Okay, that's a real safe way to do that problem, is just do a little table like that so you can keep track of it. Okay, all right. I'll have you guys do the next one here. Now let's just kind of see what you know on this. What does the x plus 3 do? Which way? It's inside the function. Inside is always left, right. Plus is left, minus is right. Okay, so you have to know that. Okay, so that is left 3, and that's always the first thing you do is left-right step. Okay, how about the negative 2? What does that do? It multiplies y by negative 2. That's what I want to hear. Okay, so you want to put here, multiply y by negative 2. Okay, now fill out your table. You'll have 3 dots to do. You're still going to have a semicircle, but those are kind of the key points on that. Okay, so just move everything left 3, step 1, then then multiply y by negative 2, step 2, and plot, and then you're good. Yeah, you got something?
Yeah, how come the problem we just did, we multiplied then added, but on this one we're going left 3.
Okay, because it's order of operations. Okay, good question. So order of operations is work there first.
Yeah.
On that problem, there was nothing going on inside those.
Okay.
Next thing is multiply, then add.
Okay.
That's why. So we did. If anytime you have left right, that's number 1. If you multiply y by something, that's number 2, and then up and down is always the last thing. Okay. Because you got to follow the order of operations when you do this thing. Okay, so here's what I'm getting. It's just basic arithmetic. So the first step, all the x's went down 3. So the first step you would have negative 5, 0, negative 3, 2, negative 1, 0. Second step, all the y's get multiplied by negative 2, so you'd have 0, negative 4, 0. Okay, does that make sense what I did? That's all arithmetic, I'm serious. Okay, so next when you plug this in and plot your points, you'd have negative 5, 0, negative 3, negative 4, and then negative 1, 0. Okay, so it got reflected. Does it kind of get stretched a little bit? That's what we'd expect that to today. And then everything got moved left 3. That's it. All right, arithmetic. Any questions? Okay. All right. Okay. That's the way I test over this. Usually I give you a graph and then I have you set up the chart and then just run through the chart. Okay. You got to know transformations and the order they go in. You got to have a question or?
Yeah.
Yeah.
Why is it up for this one, the X changed, and for the top one, the Y changed?
Okay. This is talking about this and that or?
This in the top. This in the first.
Oh, that one. Okay. So what happened on this one is the number in front is always multiplying y by something. It always is doing that. And then that number outside is always up or down. And the order you do is this. You do this first. Anytime you have left, right, that's number 1. And then number 2 is this. Number 3 is the up, down step. So what I've done on this one, see, is I started this one by multiplying before I add. I did the same thing here, except I started with left, then I multiplied. What you're always doing is order of operation. You work in parentheses. That's the left, right. Then you multiply. Okay, that's the number in front. Then you add. I'm following order of operations. I don't know if I answered that or not.
That's the last thing.
She's asking why, because on the first one you did the y side, you got or multiplied 4. The one under you went left 3 on the x side. Never mind, I know what she's asking.
She's asking why the X didn't change on the first problem.
Exactly. That's what I was getting ready to say. I don't change X at all. There's nothing going on inside that parenthesis. That's why on this problem, the X's stayed the same through the whole problem. That's why. This one, however, the X's go to the left 3. That's why the X changed. That's why. Okay? I think that's what you're getting at. Okay? So yeah, that problem above there didn't have any change in X. That's the idea. Okay. Any other questions? Okay. Okay, so we're going to do an application here. So it's tax time. I've already done my taxes, already got my refund and everything. So I noticed that refund, if you're used to getting refunds, they're probably lower this year, significantly. That's what's happening to a lot of people. I noticed that. Okay, so taxes are usually progressive. The more money you make, the higher rate you're taxed. So this is an example of this. So this is kind of a tax table. This is not the way it works. This is not the tax system, but it's an idea. So this is a piecewise function. So the idea is if your income is over 0 but not over 25,000, then you're doing 2% of your income. Okay, that's not the way it works, but it does for this example. So what we're going to have is X is just going to be your income, whatever it is. Okay, so T of X is going to be the name of the function, T for tax, of course. So we say T of X. Now what we're going to do is put together this piecewise function. So I'm only going to do the first row. All right, so what you do on this is you do 2% of your income. How do you do 2% of a number? You move the decimal to the left 2 and multiply. So that would be 0.02x. Okay, x is your income. Okay. Now we have a condition. Okay, the condition is you have to be bigger than 0, but not over 25,000. So you would write this like this. You would say 0 less than x. That's your money you're making. Then you would say less than or equal to 25,000. Okay, that's how you write that you're between 0 and 25,000. And the reason I put a less than without a bar there is because if you make $0, then what's the point in doing your taxes, right? Okay, but that says not over, so that means 25,000, that's your tax rate. Once you get over 25,000, you move to the next stage. Does that make sense? Okay, all right. Now the next thing we do is we go to the next tax rate. And that's going to be for people making between 25,000 and 100,000. Okay, so this goes like this. It says that it's going to be $500. That's like a flat tax rate, I guess. Then it will be 4% of the excess over 25,000. This is the part of the problem that a lot of times students don't understand. Okay, say for instance that you made $30,000. What would be the excess over 25? Maybe 5. How do you do that? You subtract. Okay, so what would go here is you would do X minus 25,000. Okay, like that. That just means if X is bigger than 25,000, you find how much money past 25,000, then you multiply it by 0.04. Okay, and then what that gives is that's going to be between 25,000 and 100,000. So your condition, you would say 25,000 less than X, which is your income, and then you would say less than or equal to 100,000, like that. Okay, and then that would give that tax rate like that. Okay, again, this is if you're over 25,000. That's why I use less than. Less than or equal to is the end of the tax bracket. Okay, that is including that. Okay, then the last one is 3,500 is like a flat tax rate, and then it's 6% of the excess over 100,000. So how would you write the excess over 100,000? There you go, X minus 100,000. X has to be bigger than 100,000, so you're subtracting the 100,000 from that, okay? Then it says this is if you make over 100,000. So this last thing would be X is greater than or equal to 100,000, like that, okay? That's a piecewise function, and taxes really are, in a simple form, can be thought of as a piecewise function, okay? That's very common a lot of times in business and economics practices to have things broken into pieces. That's why you learn this, okay? All right, now what we're going to do is we're going to graph this on the calculator. Now, what I'm going to kind of have you do is we're going to kind of break this up like this. This is what I think I'll have you do is something like this. Let's just go count like 1, 2, 3, 4, 5, and that's going to be 25,000, okay? 25K, you can use 25K. Then count to 5 again. This will be like 30, 35, 40, 45, 50, so we'll call that 50K. then 55, 60, 65, 70, 75K, and then 80, 85, 90. I think we make it all the way out to 100,000 like that. And you probably want to maybe take it out just a tad bit further. 1, 2, 3, 4, 5, all the way out to 125K like this. And we're going to use our calculator. Okay, we're going to graph the pieces, and we're just going to get the pieces and get the data on there. The other thing I want you to do is let's go like every two is 1,000. That's just my decision. So that's 1K, 2K, and so forth. All right, so that's how we're going to get everything set up. Okay, so this is your income right there, and then this is your taxes. Okay, so we're going to create a graph on that when we do that. Okay, all right, and I just picked those numbers because they're pretty logical to me. Now you can do this with me on the calculator if you want to, or you can just watch kind of what I'm doing here. So what I'm going to do is I'm going to graph, the first thing I'm going to do is I'm going to graph 0.02x, which is a line. I'm going to do 0.02x, and then I'll kind of talk about how we're going to do the window on this. Okay. Now,
And y equals?
Yeah, y equals 0.02x, because all we're going to do is get 2 points. They're just lines anyway. So I'll kind of show you what we're gonna do on this then. So for the window, do the window like this. Okay, you're going to go from 0 to 25,000 because that's what the problem says.
Hey, how do you put that X in there? I'm sorry.
Right here. See this button right here? XT fade in. Right there.
Okay.
Okay. Okay. You got it. Okay. Right. Now the window, what we have is 0 to 25,000. Doesn't matter what you scale by. I'm just going to always scale these by 5,000 because that's kind of what I had you do on your calculator. Okay. All right. The Y values, we're just going to go 0 to 7,000, exactly like we set this up. Okay. Now I'm going to kind of switch this as we go to the next pieces here. Okay. All right. So you can try that window, then graph, and you're going to get a line, but the line's going to end at 25,000. So if you get your window in, then you should have a line kind of going like that. Okay. Now, this is what you want to do on this is you want to trace. I've shown you how to do trace. So you want to trace at 0, and that'll give you 0. Okay, so your first point, which is obvious, is if you make no money, you don't have to pay any taxes, correct? Okay. Then I'm going to trace at the end of that, which is 25,000. The end of this tax bracket is 25,000. So I do that. And that gives 500. Okay, so that's 500. And then what you probably want to do is write this point as it's 25,000 is the X value, then 500, then connect the dots, and that shows how your tax increases in the tax bracket from 0 to 25,000. So again, what I did is this. I put in Y is 0.02X. That's what I'm interested in. And then I put in this window to get that graph. Does anybody have a question about the trace? That makes it go real fast. Okay, trace 0, trace 25,000. Okay, now we go to piece number 2. Okay, so what I'm going to do is I'm just going to wipe it out and start over again. So I'm going to put in the second piece. Not going to multiply it out. I'm just going to put in 500 plus 0.04 times X minus 25,000, and I'm going to adjust the window because I have to adjust the window. Okay, but that's the formula we get for the taxes in between basically that's in between the 25,000 and the 100. So you graph it, you put Y in. Now the window changes, and the only thing that's going to change on the window is X minimum is going to be 25,000. That's where the tax bracket starts. Where does the tax bracket end? It ends at 100,000. Okay, so that's all I'm going to change is I'm going to change that then. So this second viewing window, you just want to change the X's, and then we'll do exactly the same thing. Okay, so that's my second viewing window. All right, so once I change the X's, then just graph it. You'll have another line. Oops, I did something wrong on my window, so let me fix that real quick. I'm missing a 0. Okay, so it's 25,000. Then I need to go to 100,000 like that. Okay, 25,000 to 100,000 is my tax bracket. Now you'll see a line, and what you're going to do is trace at the beginning and trace at the end. So if you trace at 0, or not 0, 25,000, because the tax bracket starts at 25,000, you will get a value of $500. So that means this connects. So the second part is still going to be 25,500. Then you're going to trace at 100,000. So trace, and then type in 100,000. Okay, and that'll tell you how much you're taxed. So you're going to be taxed $3,500 if you made $100,000. That is not the way it is in reality, though. I can assure you that. Okay, so what you do here is you go all the way over to 100,000, and you would go up 3,500, and just label that. If you're not getting it on your calculator, don't worry about it. Get it labeled. So that's 100,000, comma, 3,500 like that. Okay, so then the next part is that line like that. Okay, and then we got one more thing to do. We do the last one. Okay, so we just go to y equals. You put in the last function, which just type over it. You'd have 3,500 plus 0.06, and then x minus 100,000. Go like that. Okay, now I got to readjust my window. Okay, what do I need to do on my window for this problem? Now, which tax bracket am I in? I'm 100,000 and beyond, right? So notice what I'm going to do is my x minimum is going to be 100,000. Okay, and then you can just pick something bigger. I'm going to go all the way to like 125,000. I think that's what I had you do on your graph. So I do this, then we'll use that trace feature to get the key points on that. Okay, so once you make that change, press graph, you'll get another line, and all you got to do is these two things. Trace at the beginning of the tax bracket, which is 100,000. Okay, that gives 3,500. So that means it's the same point here, and then trace at 125,000. Okay, I just picked 125,000. So if I trace there, I'm going to get 5,000. Okay, so the last point, and you just need to plot it, you just got that point there, which is, that point right there is 125,000, comma, 5,000. Okay, and that would be the graph of your taxes right there. So again, what this is, it's a piecewise function. This is your tax bracket from 0 to 25,000. That's your tax bracket from 25,000 to 100,000 and beyond. Okay, a lot of you didn't follow what I'm doing on the calculator, but what I'm doing is putting in the function in y1. I'm adjusting my window so it matches the tax bracket. Okay, and since it's lines, that's why I trace points out at the beginning and the ending like that. Okay, does that make sense? And you got to learn how to use technology in this world, that's for sure. Okay. All right, let's go ahead and take a 5-minute break. Let's come back at 1 o'clock. I'll leave this up here. If you have questions about your calculator, just let me know.